So in our last lecture we talked about what do you mean by center of mass, and in this lecture what we'll do is we'll just find a mathematical formulation to find the point where the mass is concentrated. So a quick review. So consider this is the origin, okay, and you have two objects, I mean say two balls. One ball say is at position here, another ball is at position here. Say first ball is at position x1, okay, and the second ball is at position x2. If the ball have same mass, so consider this is of mass m and this is of mass m, then the center of mass exactly lies between the two balls. However, if you increase the mass of the first ball, then there will be shift in the center of mass towards the first ball. So more the mass of the first ball is, more will be the shift in center of mass towards the ball, towards the first ball. Agreed? Now the main question is how to find the center of mass. Okay, so consider again that you have two balls and they are placed from the origin. One is placed here at the position x1 and another ball is placed here at position x2. Now assume that the center of mass of this object lies somewhere around here, and let that position be capital X. And remember, all the x's are being measured from the origin. Now can you tell me one thing that will happen in this system? The one thing is, if the ball 1 of mass m1 starts moving with a velocity v1, and if the ball m2, that is the second ball, starts moving with a velocity v2, then obviously this center of mass will also move with a velocity, say capital V. Now since the center of mass is a point where both the masses are said to be concentrated, hence the momentum of these two balls should be same as the momentum of alone center of mass here. Agreed? So what I want to say is, so total momentum of the system is m1 v1 plus m2 v2. Agreed? And the momentum of the system must be same as the momentum of the center of mass. So what is the mass present at the center of mass? As I said, the mass of the point where the center of mass lies balances the entire mass of the system. So at that point the mass should be written as sum of all the masses present in the system. Since this system is a system consisting of two individual masses, so what we do is we just add them. Agreed? So momentum of the center of mass is mass supposed to be present at the center of mass, which is the total mass, into its velocity. V is the velocity with which center of mass moves when both the masses m1 and m2 they move separately with velocities v1 and v2. Now let us do some tricky mathematics. So keep the m1 as it is. So what is velocity? We know that velocity is rate of change of position. So we write dx1 by dt. So that implies the rate of change of position 1. So what is the second ball velocity? The second ball velocity will be the rate of change of the position of second ball. So what is the position of second ball? It is x2 divided by dt. And mass of the ball is center of mass is v. What is the velocity? It will be rate of change of position of center of mass, and as we said, position of center of mass is x. See, our main target here is to find the position where the center of mass lies. Agreed? Now, so in the next step what we'll do is, since mass is constant, we can take everything inside. So this side will have d by dt of, so I can write m1 x1 plus m2 x2. I can do this, okay, because it's the same thing. And this side the capital M is also constant, so this will become d by dt of mx. Okay, now both side the derivative will get cancelled and we'll be left with capital X equals to m1 x1 plus m2 x2 divided by capital M. So what is capital M? Capital M is sum of mass, that is m1 plus m2. So this is the formula that takes in the value of position of first ball, position of second ball, mass of the first ball, mass of the second ball, and fetches you exactly the position of the center of mass. Quite amazing, right? So this one formula can help you locate the position of center of mass of any system very easily. So the system says, so the formula says, multiply mass of the system with the positions and add them and divide them by complete mass of the system. Agreed? Now let us take a look whether this formula actually works. Okay, so let me rub the derivation. So this part. Okay, now forget the velocities, just forget the we don't need velocities now because our application of velocity is complete. So now can you tell me, if I give you a question, okay, say the object 1 has a mass say m and object 2 has the same mass m. So literally they both have the same mass now. So mathematically m1 equals to m2 equals to m. Okay. Now suppose your value of x is 4 centimeter and value of x2 is 6 centimeter from the origin. Now logically if I ask you, so let us use logic, then we'll do mathematics. Okay, so or you can use your intuition. What will be the value of the center of mass? You know that since both the objects are of same mass, and I have already said earlier, if two objects have same mass, then center of mass exactly lies at the center. So what will be the value of the center of 4 centimeter and 6 centimeter from origin? Obviously it will be 5 centimeter. So we have 4, 5 and 6. So obviously 5 is the middle. So x is 5 centimeter, that we used our intuition. Now let us look if mathematics says the same thing. So mathematics says multiply mass into 4, again multiply m into 6 divided by m1 plus m2. Both are of same mass. This. So if you take m common, what do you get? You get 6 plus 4, okay, divided by, you get 2m. You see the masses that get cancelled, 6 4, they get 10 divided by 2, and yes, we got our answer 5. Amazing, right? So this formula directly fetches us the answer 5 without too much intuition. But this formula works very well when you change the masses. So this is case number 1 when the masses are same. So in the case number 2, if I tell you mass of first ball is say m and mass of second ball is twice the mass of first ball. In this case, guess the value of capital X. Obviously, if since m2 is larger, so as I've said, center of mass will shift towards m2. So center of mass will be somewhere near m2. So let us see if our calculation of x gives us the same value. So we have m into 4, but here we have 2m into 6 divided by m plus m, that is 2m. So what is the answer? So I guess m will get, so we'll have 12, 13, 14, 15, 16 by 2, we'll have 8. Okay, wait. Okay, so we have 3m below. Okay, so all the m's will get cancelled and I'll guess we get 6, 12, 13, 14, 16 divided by 3. So what is 16 divided by, oh, so So can you tell me what is 16 divided by 3? Okay, so just calculate it yourself. You'll find that the answer is 16 divided by 3, and somewhere it is like 5 point something, 5 point, I guess 3, near about 5.3. Agreed. So where is the new center of mass? The new center of mass is near about 5.3 centimeter when you double the mass of the second object. So this is how you play with center of mass formula. Agreed. So here I have talked about a system of two objects. If you have a system of three objects, then you do m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3. That's it. The more number of masses, just go on adding. Okay, up and below. So this is all about 1D. This is all about 1D case. Now question is how to find center of mass if we have a 2D case. So that we'll do in our next lecture.